Hi, good morning, good afternoon. Welcome to this special webinar of HiveMQ and with a couple of our system integration partners. So we're going to be talking all about data centers, and the topic is maximizing the center efficiency through real-time streaming with HiveMQ and some of the other key things that you need to do while you try to figure out like how to maximize the efficiency. So I'm going to be your host. My name is Ravi Subramanian. I'm from HiveMQ. I'm the director of industry solutions at HiveMQ. And before we get started, let me just quickly do an intro to the participants that will be there as well. Yep. And so I mean, as data centers become more and more complex and distributed, managing real-time telemetry, workload orchestration, and predictive maintenance is more and more challenging, as you can understand. And so legacy communication protocols often struggle with things like latency, scalability, reliability, leading to inefficiencies and downtime. This is where the MQTT protocol, which we'll obviously talk more about, and HiveMQ and unified namespace comes in and enables that use case. So as I introduce myself, I'm Ravi Subramanian. More importantly, I'm joined by two distinguished panelists today. I would like to introduce them in no particular order. First, I would like to introduce Kristen Davis. Kristen is a senior software engineer at BW Design Group. He's been there for 8+ years, crafting enterprise grade applications in inductive automation, ignition software, basically using that and enabling data center use cases and other use cases as well. He's an expert in architecting industrial automation solutions, leveraging Python, SQL, MQTT, RESTful API for real-time data processing, analytics, and custom reporting systems. Welcome, Kristen.
Thank you.
And then we also have Ryan Crownover. Ryan is a digital plant director at Vertec. He's an experienced architect and developer for large enterprise SCADA and MES applications. He brings a breadth of experience spanning automation systems, data centers, automotive manufacturing, database administration, and computer security. Outside of work, you'll find him doing his woodworking, building CNC machines in his garage, and keeping his 85 Nighthawk running. Would love to check it out sometime, Ryan. Welcome.
Thank you.
All right. Thank you so much. So before we proceed, so what we'll first do is we'll do a quick first 5-minute presentation, and then we'll jump into like a panel discussion. At the end of the panel discussion, we'll open it out to questions. But of course, during the panel also, if you have any questions, please feel free to ask because we want to make this a very interactive session. This is a session for you guys to help your needs out. So we're here for you. So here, just wanted to quickly introduce HiveMQ for those who don't know. We are kind of the most trusted MQTT platform. We are transforming businesses with the power to connect, communicate, and control IoT data. So we started in 2012, and we are based on MQTT, of course, but we made it like highly scalable, reliable, and secure. So it's scaling up to millions of devices, highly reliable. So adding on top of what MQTT already provides, but adding like high availability on top, for example, high SLAs on top, and then just basically solving that interoperability problem between devices and IT services, right? Bringing IT and OT together, which is easier said than done. So there are things that need to be done, if you will. And of course, we work very well with partners such as BW Design and Vertec as well, because this world is very complex. So we obviously have a solution, but we need to work in consort with other technology partners as well as system integrators. Last but not least, we also, along the way, we want to improve the quality of the data so that when you look at the data in real time, you can trust that data. And so from a data center perspective, we have multiple customers using it for multiple different use cases, right from monitoring fuel backup diesel tanks and sharing it with their customers to data center health derived from data on electrical and mechanical telemetry, power voltage, airflow chillers, and main switchboards. And last but not least, enhancing power grid efficiency by leveraging HiveMQ as the backbone to power some of the service delivery platforms. So these are some of the use cases that we have seen our customers use, and this is kind of like what we feel is the tip of the iceberg. And we're going to talk all about it in the panel as well. And so looking at the HiveMQ platform, that is the comprehensive MQTT platform where we start right from the edge, where we can collect data from different devices, to consolidating that, storing and forwarding it to a centralized broker, which can be obviously managed, fully managed or self-managed on premise or on the cloud, and then extending that to some of the IT applications that may or may not understand MQTT, like maybe sending it to Kafka or a data lake or a database or other custom applications. So again, while doing that, making it highly scalable, highly reliable, and highly available while being secure. That's kind of like the our forte. And I already summarized some of these things: reliability, scalability, enterprise grade, and compliance for the MQTT platform. So this is where 3.1, 3.1.1, and 5.0, ensuring that we are compliant with all of those features, functionality in there. And so, yeah, we are the central nervous system that connects the physical to the digital world from edge to cloud with our IoT data streaming platform. And so just kind of like an evolution of our products that we have. Obviously, we have MQTT as the base, but we also added the edge to be able to do the bridging between edge to cloud. And then we added the data hub, which is all about the data quality management and ensuring that like the contextualization of the data. And then we are evolving into the unified namespace world, which we'll talk about a little bit more. The goal is to not only like make the data available, but also to get insights out of the data. Yeah, so this is kind of like the world that typical factories or other data centers go through, where it's like a mishmash of like communication, point-to-point communication, as opposed to that the UNS world is all about like a single source of truth coming, like all the data coming into a single source of truth and going out. So definitely a more elegant and a more scalable way of connecting. And so this is kind of like a quick representation of what a unified namespace looks like, where you have a contextualized snapshot of all of your data coming in from your factory machines, maybe a data center, all the operating machines, other systems that also needs to be there to complement that information, so that you can then build out like applications and things that obviously we'll talk about, like some of those applications as well. So that's all I had from a presentation perspective. At this point, I just wanted to stop my share so that we can see each other, and let's just jump to the panel. So thank you again. So let's start with you, Ryan. I have a question for you. So we talked about real-time data. What do you think is the role of the real-time data in optimizing power, cooling, and IT infrastructure in modern data centers?
Yeah, Ravi, that's a great question. And I like to frame this idea around data centers are becoming a utility, right?
Ah,
They're no
yeah.
longer just a service. We're no longer just pushing out applications. They're a utility just like water or the power grid itself is to services that we use every day. So we
Hmm.
need that same real-time visibility that we need for those types of systems to understand um, how is all of the infrastructure that's supporting these services working? We have to get alerted at what's going on. We have to know what's happening. And we need to be able to see faults and see issues and catch those before, really catch our redundancy items
Hmm.
before those fail, right? Undiscovered errors typically lead to those real failures. And then in the modern data center, as the consumption of energy density goes up,
Hmm.
as chips get faster and faster and need more and more power, you really do need real-time visibility and automated real-time control of
Mm.
where loads are being placed in those data centers so that you can manage power because you cannot. We're getting to a place now where you cannot turn all the servers up to 100
Yes.
and not totally wreck your power infrastructure.
Oh, absolutely. Totally agreed. And it's interesting that the where data centers have evolved is very, very interesting. Kristen, I know you were like vehemently shaking your head as well. So would you like to comment on that?
No, I totally agree that data centers are becoming more and more of a utility. I mean, when you think about how many things have cloud storage, how many things have AI power in them, it seems to be all over the place. So I
Mhm.
totally agree with Ryan's comments.
Awesome. Great. Yeah, so just a question, and again, I'm wearing multiple hats here, so it's weird, but I'm going to ask a question for myself. So how does HiveMQ help bridge the gap between legacy systems and modern cloud or edge analytics tools for data center use cases with unified namespace? Now, I kind of like touched upon it. So basically, like providing that whole end to end, because obviously data centers, and Kristen, you're going to touch upon it, right? A lot of data centers have SCADA systems like Ignition, for example, and it is using a lot of MQTT, and it has a lot of other protocols. So bridging all of those different protocols, bringing the data in, making sure that you have like all of it is converted to say MQTT if MQTT is the way you want to do it, and then bringing the data into like a centralized repository, like a centralized broker, and then from there making sure, and while you do that, making sure that the data is real time, high quality, and it's trustable, it's scalable, so that like if anything is lost, like say a power is lost, for example, on one node, you're able to have a backup node because obviously your data center has very, very high SLAs that you have to provide to the people, right, that are using it, right? If AWS and Azure is going to use your data center, you better like clean up your act in terms of providing high SLA. So it's very important that you do that. So you need solutions like a HiveMQ that is able to provide that level of enterprise grade support. So those are the key things. I think Ryan already touched upon some of the key use cases, how data center is becoming like utilities, and what are the things that are becoming key in data center. So, and then unified namespace, real quick, is just, and we'll talk more about it during this conversation, because that's kind of like it's a framework that allows you to be able to bring all of your information, all of your business data into like a single source of truth. Now, is there like a single tool, like a single provider that can help support that? Not, right? It is a concept, right? So HiveMQ has a perspective on that. We feel that MQTT is the right way to do it because it is borrowing the concepts of MQTT, but there are other ways to do a unified namespace. As long as you're able to bring all of your business data into one location, and it's all edge driven, meaning like wherever the source of data is, you're able to get the data from there, consolidate that along the way, because you obviously have many, many different edges, many different locations that you have to bring the data from. And then you're able to bring it all into one location, contextualize it, and make it available for your key use cases. That's what a unified namespace is. So yeah, so just wanted to bring that up. All right. So next question is for Kristen. Apart from like a data center or a data broker like HiveMQ, what are some of the other pieces of software that makes a typical data center architecture?
Yeah, so I mean, with any good MQTT architecture, you would have a publisher and a subscriber. So you need something to mold that data. We talk about the unified namespace. At the edge, you really need to look at the different protocols and the different types of devices and mold it into your unified namespace so that you could publish it to the broker. Now, once that data is in the broker, you can send that off to your cloud and directly store it into a data lake, as well
Mhm.
as you can put that into a visualization tool and standardize all of the equipment that you have across your entire data center. We use
Mhm.
Ignition, and I can't speak to how much the UNS and MQTT makes my life immensely easier in terms of
Mhm.
aggregating thousands, if not hundreds of thousands, or even millions of data points in a single place to be able to be utilized. So, in addition to a visualization system, you might have SQL databases locally to your data center to store historian and alarm information that could be analyzed by the on-site operators. You might also have REST endpoints that you use to
Mm.
pull in utility information. So we've seen some of our clients actually get some sort of pricing data from the utilities to see what the cost of energy is.
I
Because if
see.
they're doing something like AI training, maybe they don't have to have high availability. Maybe they can actually dial down the level of training that they're doing while the prices are very high. So we've
Mhm.
seen some things like that. And then as these data centers start to scale and you start to see this whole web of data come together, a lot more advanced virtualization tools such as Kubernetes are being more and more prominent in the space. And something like HiveMQ really makes it easy to do that with their Kubernetes operator. I mean, right now that's one of our go-to options in terms of how we integrate a HiveMQ broker and a high availability ignition system.
That's awesome. That's awesome. Ryan, did you want to add anything to that?
I think Christian pretty much hit it. It's realistically, it's the same components of architecture that you would have in any other sort of industrial utility kind of scenario. And that's not to minimize it, but to identify and I think kind of support that this idea that it really is a utility that
Yeah.
has to be maintained in uptime. And the more we think about it that way, uh,
Yes.
the more we can cross apply the lessons we've learned from the other places in the space and
Yeah.
get some really useful moves out of it.
Yeah, it's interesting because when you think about a data center, you think it's pure IT, right? But I think the world that we're living in, it's not really. To your point, Ryan, it is a utility, which means that there is an OT world and there is an IT world. It may not be exactly the same as a factory, but it's kind of like equivalent to that. And then as long as we treat it similar to that, I think a lot of the things that we have within, say, a manufacturing or oil and gas can be applied to the data center use cases as well, which is great. Fantastic. One follow-up question is like, Kristen, you touched upon MQTT, you touched upon how historians and other technologies come in. What about the role of Sparkplug here? Obviously, when we're talking about inductive automation, data coming in Sparkplug, and how is that managed, if you will, within the? Can you maybe touch upon
Sure.
that?
So Sparkplug B, I think, makes it a lot easier to enable that UNS structure. If you look at a Sparkplug message, it has the full path generally of your devices, which generally makes it easier to develop that UNS. And
Mm-hmm.
as well as there's a lot of functionality in Sparkplug B that makes it bidirectional. So we have a use case actually where we have separate publishers. And so we have a publisher on the IT side doing some leak detect monitoring of their servers. And we have some PLCs that are doing some control of what's going on there. And they can actually send information directly to our PLCs to shut them off if they detect a leak and we need to turn off pumps or things like that. And
Yeah.
that really wouldn't be possible without Sparkplug V.
Yeah, great. I think Sparkplug B has a lot of great use cases, especially in the command and control space where you want to control certain, yeah, PLC motions and things like that. That's fantastic. Just a follow-up question on like, and you probably already touched upon it, Kristen, but the advantages of using, say, an MQTT over like maybe other traditional protocols like SNMP or Modbus in data center environments. Maybe you can touch upon that.
Yeah, absolutely. I mean, one of the easy ones is always how lightweight it is,
Mm,
and it's a publish subscribe, right? So if I have hundreds, if not thousands, of data points or set points rather, I don't necessarily need to constantly pull those set points. Those set points are more often than not changing very often. So it tremendously lowers the network bandwidth that you're utilizing and allows you to prioritize the information that is critical to your application.
hmm.
So in addition to that, you can filter topics on the subscriber side. So if I only care
Hmm.
about certain data points, I only have to pull those in.
Yeah.
It makes it so easy to be flexible and very modular. And that's really one of my favorite parts about MQTT in general is
Mhm.
it's just so modular. You're able to just plug things in and remove them without
Yeah.
really affecting the global construct of your application. Um, and like I mentioned earlier, it has that bidirectional functionality, so it makes it really easy on your front end as well to control set points that are managed at the edge.
Yes.
Um, one other thing that I really do appreciate about it is that it is very secure. Security is the forefront of data centers, and it
Right.
supports things such as TLS and SSL, and
Yeah.
it's just a game changer, realistically.
Yeah. Yeah. The other thing, Kristen, is like, and of course, there are many other things, but one of the things that I appreciate is like the quality of service, if you will,
Yeah.
the ability to do message guarantees, right? Either just broadcast or you get like one acknowledgement or you things like that, right? That you can set up depending on the kinds of messages that you send. The flexibility that you have is fantastic as well. Ryan, anything you would like to add from your perspective?
Yeah, I would just say on the that really fundamental idea that if you're using Modbus or SNMP or some other
Mm-hmm.
polling based idea, you
Mm-hmm.
have to own the central infrastructure and have access to the central infrastructure in order to add devices and add data and contribute to information. So the coordination and the planning and the business logistics problems you have to solve in
Yeah.
order to manage that data set enterprise wide and have
Yes.
governance, it just slows everything down.
Yes.
Fundamentally, with MQTT, you can at the edge device level will decide everything. If you know the unified namespace and you know where that device sits in it, everything
Right.
underneath that device can just be owned by that device. That
Right.
device can say, hey, this is my data, I'm publishing it, and now it's appeared inside of that namespace and it owns everything underneath it. And it's the same strategy that if you're any sort of package management software in traditional software development uses this namespace concept
Yeah.
to make sure that there aren't naming collisions for data.
Sure.
And so the speed that you get, and not just through being able to do it quickly, like in time, but
Yeah.
this you get in reduced organizational drag in business
Yeah.
processes to
Yeah.
be able to deploy new devices, get them integrated into your unified namespace or your company's data stream,
Sure.
and be able to adopt those things. Complete game changer over protocols where you have to manage the structure of that data only in the central location.
I see. I see. Great. Thanks, Ryan, for the feedback. There are a couple of questions. Actually, I would urge people to put their questions in the Q&A section rather than the comments. I do see a couple in the comments that I'll quickly ask. I think we talked about Sparkplug. Is it possible to show some use cases of Sparkplug and virtualization? I think, Kristen, you quickly touched upon that, right? One of the use cases of Sparkplug within data center. Maybe you can elaborate on that.
Sparkplug in terms of visualization or virtualization?
It says virtualization, but maybe let's just focus on use cases of Sparkplug, right? I mean, maybe you can touch upon
Sure.
that. Anything
Yeah.
else?
So like I mentioned earlier, it's bidirectional, so you can use the broker as a centralized way of talking between different edge devices. So, like I mentioned earlier, if you have a front end that needs to communicate to a PLC out on the edge, you can monitor those set points, modify those set points, do whatever you need to do there.
Yeah.
Likewise, you can have IT systems that monitor those IT racks and can also publish data to the edge to then update that information and change those values.
Yes.
It's really useful in terms of creating that unified namespace. I think that I'm not as familiar with other variations of non-Sparkplug B. It's because we use Ignition, we're always using
Yeah.
Sparkplug B, and what I've learned just in my experience is that it just makes it so much easier to do. Like it's honestly something that you don't even really think about for
Right.
the most part once you integrate it.
Yeah, absolutely, absolutely. All I want to add is that it's awesome. It's awesome for the use cases that you mentioned. For those aspects of the ecosystem that does not Sparkplug, you have to do some conversion, if you will, right? If you have an IT system that is trying to also talk to like Sparkplug enabled systems that doesn't understand Sparkplug but does understand MQTT, then there might be some data conversions that are needed from like Google Protobuf into JSON or just Sparkplug to straight MQTT. We have seen that as well, but I think like, yeah, if you're within the ecosystem, then I completely agree with you.
Yeah,
Anything
well,
else, Ryan?
I'll highlight that, Ravi. What you kind of just mentioned is that we have a handful of data center customers where we're doing exactly that.
Mm.
Spark B is excellent when we're talking about managing the infrastructure and devices, but
Hmm.
when uh, we want external services, right? Business services, and because these companies are using their MQTT data outside of the context of the data center. They've got
Right,
other data and other information that they're using. They're wanting to feed data back into
right,
the data center. Sparkplug actually starts causing problems in that space
Right.
because it's just a different form of data. And so we've had a lot of success using Data Hub and the other
mm,
tools that are in HiveMQ
right.
specifically.
Mm.
Just fantastic performance
Yes,
to be able to translate massive amounts of data in real time from Sparkplug into what we generically would call vanilla MQTT, which is just
right,
our term for everything that is not Sparkplug.
right.
Um,
Exactly.
that
Like
we
that.
use, but the advantage that we get out of that is significant. And all of that's still accessible from the broker. So,
Okay.
across the enterprise, they can still go get that Sparkplug B subscription if they want it, but they've also got those fanned out messages as
Yeah,
well, and that enables a lot of different business systems to interact
absolutely.
with it.
Thank you. Thank you, Ryan, for that color. So the questions are keeping like coming in, which is good, which people are not shy. I'm just going to poke over to those questions and then come back to our regular questions as needed. And I think like as we are talking about these, we're already bringing out the points that we wanted to talk about anyways. So the next one is, do you use AI in any aspect of data collection, filtering, and brokering? Right? So the use of AI. I mean, I can start on this, right? I think for us, the way we would like to think about AI is that it is a tool that needs good data, right? From a data management perspective, you need a good tool. So the actual currently, at least the data collection, filtering, and brokering, it's not using AI, but in the future, we do plan to use AI for like maybe some insights gathering, some basic insights gathering out of this that we can then be able to send it out to other systems that need that information. But today it's all about like ensuring that the data is real time, it's contextualized, it's good quality, it's ready to go to support you in your quest for creating good quality AI models. That's what I would like to say on that. And then there was also a question, maybe this is for you, Kristen. Do you
Yeah.
have an opinion on other skaters like Aviva, Factory Talk Optics, Niagara versus Ignition?
Sure. So I actually recently got exposed to Factory Talk Optics. I went out to a Rockwell training and got some information on there. I think the main issue with Factory Talk Optics, even aside from data centers, is that it's just not ready to scale to like enterprise-wide applications. So that's why we haven't really implemented the Factory Talk Optics, but we are closely monitoring Factory Talk Optics as an option in general for SCADA.
Right.
And in terms of Aviva, I don't have a strong opinion on Aviva. I do know that we have clients that have data centers on Aviva and they are trying to transition towards Ignition.
Right.
But I'm not certain as to why those reasons are.
Yeah, yeah. I think it just goes back to the technology it supports. I think like you have MQTT, Sparkplug, and all those technologies that are very ingrained in the use cases that we are using, and so that's
Mm.
one of the reasons why it has a lot of advantages over these some of these other tools. So one of the question is like, hey, are you using HiveMQ Edge for the data gathering part? Yes, HiveMQ Edge can definitely be used, but there are obviously other options, right? Kristen, obviously you work a lot with Ignition Edge, which is a
Mhm.
great tool and it's a fantastic tool. HiveMQ Edge it has its place, of course. I mean it is for like small footprint use cases, if you will, where you don't need an ignition edge or you're starting off green, you want to like to start off with some open source way of doing things. It's definitely an option. Any comments on that from either of you?
No, I think you hit it, Ravi. It's an option to enable collection at a certain point, but at the end of the day, what really matters is that
Hmm.
uh, we get the data into that MQTT stream published to the
Exactly.
broker, and however that happens is really just fine, and kind of the
Exactly.
more the merrier in terms
More
of
than that.
devices and applications that can support
Right.
publishing to MQTT.
Right. Yeah. So for us, it's like if you're going into a customer opportunity and we already have Ignition Edge, which typically is the case, right? We're not going to say, no, no, use HiveMQ Edge. You can use that. And then obviously we support MQTT. We can bring the data into our broker. That's exactly what we would like to do. We offer Edge as an alternative for those use cases where you don't have anything because our goal is to bring data into the broker. So you can do stuff with it. You can create the unified namespace and things like that. All right. There are many, many questions on the Q&A. So I haven't even gone to the Q&A panel, by the way, because there's questions on the comments here. But I would like to ask some questions on the Q&A panel here. What part of the system integration would you decide sending data only when it changes? Real-time data assurance is critical for OT. How an OT system can be sure other parts of the system are not offline? That's a question from Marion. Marlon, sorry, yeah. would you like to talk about maybe from a system integration perspective, how do you make sure that you only send data that when it changes? I think isn't that like an inherent part of using MQTT because it's
Yeah,
all
so MQTT, whether it's MQTT, but Sparkplug B, right, has all of that report by exception publishing
Mm,
built in. And so, that's built into the protocol. There's in the MQTT protocol, right, that quality of service or that QoS feature where if it's 0, we don't have any. If it's 1, we're going to guarantee that that message um, gets sent all the way down to everybody that's subscribed to it. And then you can go even higher in that with a QoS2 setting to
yes.
really ensure that those messages are all getting delivered.
Hmm.
And it's really important that you've got a broker that can handle the potential throughput and potential buffering that you might need for having a bunch of offline clients. Um, and so that's something we've experienced. It is a thing that you need to think about in terms of, does this really need to have a high QoS rating for,
Right.
particular set of data? But at the same time, that sort of only send data when it changes is really a part of that. There is a consideration for um, how do I get that set point data that doesn't change a lot? How do I
Yep.
get access to that when I'm a new client that's subscribed, right? That's the set point data isn't getting published. Um, there's a concept of, the broker being able to retain those messages and provide them, on subscription for the
Awesome.
clients. And we leverage that from HiveMQ in a lot of scenarios so that we're not streaming that set point data on some sort of set interval.
Yeah.
And so there definitely considerations, and there's some gotchas baked in there, but
Mm,
definitely all solvable problems.
awesome. Kristen, any comments from you on that?
No, I'm good here.
All right. Oh, good, good. I think there is a follow-up question to that, Ryan. Can it be guaranteed that MQTT messages are always delivered from the client to the broker? What happens when there are network hiccups or short-term communication losses in an unstable network?
Yeah, I would say that just depends on that publisher,
Yep.
however that publisher is designed, right? So you've
Right.
got, as an example, Ignition Edge is going to have that store and forward buffer that's going to be built into it. So it's going to make sure that those messages get delivered.
Right.
It's going to buffer those appropriately, but it would really depend on the publishing client
Yes.
to to get those messages delivered.
Yeah. Yeah.
I got a
One of
comment
the things.
there.
Yes. Go
Go
ahead,
ahead.
Kristen.
Well, I was just going to say, one of the things we do to ensure that our devices are actually connected, to Ryan's point, it depends on the publisher. So in Ignition, if you're connected to devices, it has an
Hmm.
inherent connected tag, like system tag. So you can monitor that with your device, like inside your UDT, and publish that data along with it. So if there's any changes to it, you can actually publish that you're not connected to that device anymore and have
I
that
see.
visibility.
I see. Yeah. So a couple of things. HiveMQ Edge, while we're talking about that, is also does the same thing, the store forward, because obviously that's a key thing, right? Connectivity is lost, and you have edge systems that are always kind of like straddle for resources. So you have that. But then on the broker itself, I think we store to disk, which means that if for whatever reason the broker goes down, the information is not lost. And this is in a scenario where you want to do broker to broker communication, if you will, right? You have like multiple layers, maybe like in the world of manufacturing, a plant broker versus an enterprise broker, or maybe other ways of your networking as well. So you have that. Great. So there's a lot of questions around AI. Of course, we opened the Pandora's box when we talked about AI. Our good friend Rafi Shahid has some questions around, do you really want to put your info from your data center into an external AI engine?
Yeah. I probably not. Is really the scenario there. We have been working on a project with NVIDIA and Phaedra where they're actually using some AI on the backside so that they can consume that AI that Phaedrus built can consume data from the data center, and we can put real-time cooling and power feedback back into the data center,
Right.
going in the other direction. That AI isn't external. It's a custom-built tool, so you can definitely leverage AI for these scenarios. But it is, yeah, we wouldn't recommend just pushing all of your data into ChatGPT or something like that. And
Yeah.
it's worth noting too that just on the AI, right? It's really important that we're always talking about what kind of AI.
Mm-hmm.
So an LLM is not going to do anything really, really useful with your data center
Right.
information. You're going to
Right.
need a different kind of machine learning model to really get good content back.
Right. Right. Great. Anything else, Kristen, that you wanted to add?
Yeah, no, I totally agree. I mean, you would definitely want to have a tailored AI solution localized in your enterprise. So as you're pushing that data up from the edge to the cloud, you're contextualizing it. And to Ryan's point, you're using a model that is relevant to the information that you're trying to detect and actually understand what your anomalies are and things of
Mm-hmm.
that nature.
Yeah. Yeah. And then there's a follow-up question again on AI. How's the performance, reliability, latency if experience exists in a bidirectional AI optimization algorithm environment? So I guess they're talking about how do you ensure high performance, high reliability, high latency if you're trying to do some AI optimization.
Mhm. So the fundamental strategy that we've taken is really that the AI service is non-critical.
Yes.
Right.
Hmm.
So the power and cooling systems, all the infrastructure for the data center that you're managing, you really want all of that to work. And then you give the AI the ability to request changes to what's happening. But ultimately, the AI isn't in control. It at best it just gets to request actions to be taken, and
Hmm.
ultimately that control system has the final call on whether or not you shut off this cooling loop or open this breaker or whatever other scenario that might happen. And from there, it's just a performance tuning problem in terms of how well you can get all that to work.
Yeah, absolutely. Anything, Kristen, from your perspective? Okay,
No,
let's go with a non-AI question. How about
yeah,
that? Take a break from AI, which is hard, which is hard. It is the
yeah,
800 pound gorilla, right?
yeah.
And so Ryan, can you like share some examples where system integrators accelerate digital transformation for data centers using HiveMQ and some other key software components? Maybe just
Mhm.
touch upon some examples.
Yeah, absolutely. I would say the biggest way that we've been able to speed up digital transformation in data centers is enabling the faster deployment of data centers.
Yeah. Hmm.
So MQTT, specifically Hive, you know, but also Ignition. And not even, I know the question was about systems integrators, right? But you've got Vertiv, one of the biggest,
Yep.
data center
Yep.
hardware suppliers. They're starting to white label Ignition Edge into their devices to be able to publish Sparkplug B. So what this really gives you and what we're doing as a systems integrator is really building tools to be able to help these data center operators deploy faster. Whether that's that things are fully modular, or
Mhm.
we're able to just do it quickly and manage those models and make those edits and get to quick deployment. But it's really about enabling the speed because um, data centers go up fast and they don't last long in the scheme of things. That's one,
Right.
at the top of the webinar, we were talking about data centers are so much like infrastructure. One way they're not like traditional infrastructures, they don't last very long in relative timeline. you could count their age better in months than years. And so that's a speed to implementation is a big point.
Yes. Yes. Awesome. Kristen, anything you want to add on that?
Yeah, I completely agree. I mean, basically every client that we're talking with is trying to expedite that deployment process. And to Ryan's point, Vertiv is deploying this unified solution where basically they can factory acceptance test or L3 their skid at the factory. And then whenever they get on site, all they have to do is L4 and L5 or do an integration system test.
Yep.
And that just dramatically reduces the amount of integration time that you spend on site and dramatically increases the amount of time that you can actually spend up and providing services to your clients.
Yeah. Yeah. Makes sense. Makes sense. Next question to you, Kristen. Obviously, we talked a lot about like the southbound connectivity and things like that. What about like trying to other software pieces that you can connect to be able to complement some of the things like a Grafana or an Influx or other cloud services that you want to connect to get like a more kind of visual view of like how your data center is performing, build dashboards and things like that. Maybe give some
Yeah.
examples.
Absolutely. So, I mean, at that level, you could use Ignition, but we see a variety of different solutions used at the enterprise level because honestly, once you get the data up in the database,
Right.
you can use pretty much whatever software platform that you want to be able to visualize that data. So we see
Right.
plenty of clients use Power BI or something like
Mhm.
Grafana. Once that data is in either like something like Snowflake or MongoDB or whatever data lake flavor that you prefer.
Mhm.
As well as, if you're like an AWS house or an Azure house or Google Cloud house, there's all these connectors that allow you to connect your plant broker to your data lake and things like that.
Yes. Yes. What about Kafka? Do you see a lot of use case for Kafka?
So not yet, but
No.
I think as 8.3 for Ignition gets rolled out in the near future, I think it's supposed to get rolled out in the next month or two.
Okay.
One of their big pushes or their big announcements at 8.3 was Kafka event stream functionality. So I
Nice.
think as that becomes more readily available in the industrial space, we'll start to see that more and more often.
That's fantastic. Looking forward to that. Great. So the next question is to you, Kristen. How can, and maybe we already touched upon it, but like how can MQTT and real-time streaming reduce unplanned downtime and improve SLA compliance?
Yeah,
Ryan,
absolutely. So
one.
because you have visibility into all of your data points, you can monitor your entire data center. You have
Yep.
complete visibility into everything that's going on. So if you see spikes in temperatures or tripped breakers, that's a first sign that something is going wrong and you can instantly take action. So with MQTT, you have that instant critical event notification. So you can see instantly when certain things are going wrong. And that'll
Mm,
immediately prevent unplanned downtimes. If you see certain temperatures are spiking, maybe you need to transfer your load from one side of the data center to another, from one data hall to another data hall.
yeah, great.
Doing things like anomaly detection definitely help. Like as you build up this data lake, you can understand more about what your patterns are. Maybe you have an unstable grid and you see that at certain times of the night, you're getting these spikes in power and it's causing your breakers to trip, and that just causes a whole downstream effect of issues.
Yeah, yeah, that's awesome. Ryan, would you like to add anything to that?
Um, I would just double down on the biggest one is load management. Uh,
Yeah, yeah.
right, is visibility for alarms, and the big one we all know from the manufacturing space, we're really good at coming up with no single point of failure. Uh,
Mm-hmm.
but those systems still end up with downtime because we didn't properly alert on the first failure. So the
Yeah.
second failure ends up taking it down anyways. So
Mm-hmm.
alerting on first point of failure and load management to prevent failures,
Yeah,
absolutely
yeah,
uh, two biggest values.
yeah. It's interesting. I remember coming back from Hanover Messe last week, and I was chatting with another vendor that offers these AI-based solutions. And one of the things he said was very insightful, right? people are not always looking for predictive maintenance of their machines because like they always have backups. Like if you have a pump, for example, right? You typically have a backup pump already available. So if it fails, if this main pump fails, so what? I mean, you have a backup pump that is already there, right? But what you're really selling is the energy management, right? If you can actually like try to reduce the energy management of that pump, that is huge for the operations, right? So you really, yes, while you're trying to help predict failures with collecting all those data points, but really what is tangible for them today is how you can help reduce energy of their operations, which is huge because I think they're also trying to go towards like carbon footprint reduction. That's kind of like that lofty goal, but the beginning is like how I can reduce my energy and increase my throughput while reducing energy. So
Yeah.
interesting.
Well, and Ravi, to that point too, I'd just add, you do all this, you put all this into your data center so that you can catch real-time items and issues so that you can manage your loads. As we get into a place where more and more people are going to need regulated carbon accounting,
Yes.
then all of this data just goes straight into those systems that can
Yeah.
pull that off. And
Yes.
you can start to
Yes.
get solid reporting. You're going to end up with all of that data input for free,
Yes.
provided you're using some of these concepts of
Mhm.
unified namespace, of
I see.
manageable data governance and architecture. You're going to
Yeah.
be able to just push that data right into that carbon accounting software as just another consumer from your broker.
Yeah. 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 So since you mentioned the word unified namespace, I'm just going to like fork into that directly, right? Because I think that's something that everybody is talking about. I think obviously we were at Prove It, Brian, and I know that we had a lot of great conversations around unified namespace. It is a framework. It was a buzzword not too long ago, but I think like the rubber is meeting the road, so to speak, right now, because you have tangible solutions that are out there, partners that are coming together to create real solutions, customers that are actually using it and seeking benefits. So maybe you can touch upon that, and maybe Kristen, you can also jump in as well on your kind of like idea of unified namespace. How do you go about like trying to set these things up with your customers? How do you talk about it, if you will? And what is the role of vendors like HiveMQ and others in the space?
Yeah, absolutely. I mean, unified namespace, right? It's, as you mentioned, it's grown into a somewhat of a phenomenon in the industry, and now we're really
Hmm.
getting to the point where people are implementing it and starting to get use out of it. I think where we're at now and what we work on with our customers specifically is that you can't go buy a unified namespace.
Yeah.
Um, you have to build one,
Yeah. Yeah.
and
Exactly.
what that really means is that as much as you might have it, where it's implemented, where you get the data to and from, what protocol you use to accomplish it, all of those things are secondary to this idea that you do need to define what
Hmm.
that named hierarchy is. And
Yeah.
um, I know this is not a webinar about HiveMQ Pulse, but
Yeah.
what y'all are doing with that product and growing um, really gets into the definition and the governance of the data
Yeah.
and how to actually design the structure of that unified namespace. You really need a system that can own that structure,
Right.
um, and then enable all these devices to publish into it. So
Yeah.
that's what we focus on with our customers a lot. We don't talk UNS. We don't sell UNS, but it is the mechanism and the theory and the thought behind how we architect the data, across the enterprise. And it
Yeah.
really makes a big difference when we start. Uh, we treat data centers like they're large multi-site infrastructure because of just the number of devices. But it's the same thing if you wanted to see across multiple data centers, you wanted to do an
Uh,
enterprise roll up of those things, then um, that's when it becomes really important to keep to those fundamental principles.
yeah. Very, very well said. Kristen, do you want to add your two
Sure.
cents?
Yeah, so whenever we're thinking about a UNS or working with our clients to help them understand how we architect our UNS, I always like to give the example of like if you were to take, a bird's eye view and kind
Hmm.
of dive all the way down into a specific temperature sensor. There's many levels that you get like go through in order to get to that temperature sensor. So you might start at your enterprise level. Maybe you're looking at many different sites. Then you go to a
Right.
specific site. You go to a building. You go to an area. You might go to a room. And like it just kind of keeps going down and nesting. And that's essentially how you have to build your tag structure at the edge. And once you have that tag structure at the edge and you have
Mhm.
many of these devices at the edge, this UNS structure allows you to just kind of, for lack of a better term, zipper them together in this UNS and contextualize the data across your entire data center and all of your distributed systems into a common place for you to then aggregate up to another place or do an enterprise roll up, like Ryan was saying.
Yeah, absolutely. Absolutely. Let me ask a question here that was posted by Ken Murphy here. Many hyperscalers employ a real-time load control system that throttles CPU, GPU utilization based on power meter readings to allow oversubscription and maximize capacity utilization. These applications are latency and reliability sensitive. Is MQTT Sparkplug suitable for this application? Are you aware of any existing use cases? Maybe Kristen, because you were speaking, you can jump in.
Sure. So I think in this case, I think Sparkplug View would be fine, but I think you might want to consider your quality of service level.
Right.
And we talk about the different QoS levels. If you're just reading sensor data and publishing sensor data, you don't really care to have that level of handshake. But if you're reading hypercritical systems, you might want to consider QoS too, and to have that additional handshake to verify that all of that stuff is being responsive.
Yeah, great. Ryan, any comments from you on this?
Yeah, I would say we are transporting those commands across Sparkplug B in some scenarios. So we definitely think it is suitable. We're actually doing it in some places. But again, comes down to the request management, um, of making sure that those external systems that are managing that control system ultimately has final say on whether or not valves get closed or opened, or what happens with the power equipment.
Yeah, yeah, excellent. Uh, I mean, we are getting almost towards the end, guys. The questions are pouring in. I think we're answering as we are getting it. So keep those questions flowing. And if obviously if we cannot address them now, I'll make sure that myself, Kristen, and Ryan take some time to answer the questions offline as well. But just a couple of other questions that I wanted to touch upon. One is, Kristen, for you, what metrics or KPIs are the most important in tracking improvements within data center operations?
Yeah. So I think an easy one is something like uptime percentage, like how
Hmm.
often are your servers actually running? Um, Another one would be like your outage frequency, like how often are you actually having outages, either internally or having power outages from your utility, and
Hmm.
understanding what that frequency is to comply with your SLA.
Hmm.
But another thing that I like that we carry over from the MES side is your mean time between failures. So how often are you going, or how long are you going between one failure and another? And
Yeah,
trying to drive that number to be higher, right? Like you want to have more time between failures. In contrast, what is your mean time to repair? So
yeah,
whenever I go down, how long does it take us to get back up and running?
yeah, yeah,
Um, as well as your incidence response time. We talked about these hypercritical applications and all of this real-time metrics flowing of critical information. How often are people responding to critical things and getting those resolved?
absolutely. Anything from your side, Ryan, to add to this?
No, I think,
Okay, good.
yeah, Christian
It's a good
got it
list.
covered.
Thank you, Kristen. Yeah, so one question for you, Ryan, is like, what are some of the lessons learned or pitfalls to avoid when rolling out MQTT, UNS, streaming infrastructure in a live data center?
Yeah, absolutely. There are a few of those. We've definitely cut our teeth on these things. Uh, one we've already talked about, which is QoS levels. Um,
Yes.
One, use them where you need them. But two, don't just slap a QoS 1 or a QoS 2 on everything because you think it's all important. You do still
Yeah.
need to think really critically
Right.
about what it is. The other thing is that scale happens fast. So if you're coming from the traditional integration or manufacturing world, uh, you're used to a level of scale that is typically an order of magnitude. Maybe it's two orders of magnitude um, in your multipliers. And we're kind of accustomed to that in our brains. It's very hard for our human brains to comprehend the scale that data centers are expanding at when we talk about what is the data structure for a particular device, what is it publishing to the namespace.
Right.
Realize that you're going to be multiplying, if you're talking about um, a particular RPDU or something like that, you're going to be talking about multiplying that by thousands, not
Mhm.
hundreds. And
Yeah.
so scale goes real big, real fast. So you have to be very economical, despite the fact that we're in a data center, that we're in 2025, that we should be able to get all of this data. The scale still means that we have to be really economical with what data points we're capturing, how we're capturing them, what kind of message frequency we have uh, there. And then I would say, what you're doing with your retained messages and what
Yep.
you're doing with data that really isn't telemetry data. So
Yep.
the data that isn't actually changing over time or isn't a set point, all of that, you might call it relational or descriptor data. Are
Yep.
you stuffing all of that into
Mhm.
um, your UNS at the device level,
Right.
or is there somewhere else that your system can go and grab that data
Right.
so that you're not smashing that stream? Or do you need to insert it into your stream from a different place, right?
Yeah.
Can you have a
Yeah.
different system
Yeah.
manage all of that?
Hmm.
Those things have been
Yeah.
really significant and are problems that I think um, Hive and other vendors are starting to address with some of the changes and the things in their products, but at the scale we're operating at in data center land is really critical.
Yeah, absolutely. Great feedback and great suggestions. Kristen, I'll wrap up with you. I mean, maybe you can talk about, what are some of the, again, from your perspective, right? I mean, some of the key investments, and maybe Ryan, you can also jump in. Some of the key investments that are needed. Like if I'm starting off on this journey to improving my data center, what are some of the investments that you need to make in terms of technology and other things?
Yeah.
Customers.
I think it's really important, like Ryan mentioned before, scale happens really fast. And so I think it's really important to consider how fast it's going to scale and prepare for that at your edge level so that as you move up in the layers, it's much
Mm-hmm.
easier to aggregate all of that data. Additionally, um, man, I just lost it.
Mm-hmm.
Ryan, maybe jump in for a minute and I'll see if I remember it.
Yeah,
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 similar to what you're saying, Christian, I would say it's tools and capabilities that enable fast deployment.
yeah,
Whatever it is, the architectures, startup time needs to be real slow. Equipment's installed, to turn it on the next day. Um, and that's really whatever you can do to maximize that speed, everybody gets to win.
yeah,
I did remember the thing that I was trying to think of. So one of the things to consider, especially on your EPMS side, is the modularity of your equipment. So when you think about, if you're going to roll out 5 buildings, building one is just inherently going to be different than building 10, depending on, lead times and things like that. So prepare for being able to handle a variety of different equipment, types of equipment, data models and things like that.
yeah, yeah, absolutely, absolutely. I think we're almost at time here, guys. I believe we have answered all of the questions. There was like one open, hey, can you organize such webinars for specific industries, just like data centers, like chemical plant or and others? we'll absolutely do that. And then like for those who want the recording, yes, we'll definitely make that available. And then if there's any questions after the fact, you're like, man, Ryan said this thing or Kristen said this thing. I wish I'd asked this question. Please reach out to us. We're happy to answer any questions after the fact and set up any follow-ups with you guys in terms of what you want. But I want to thank our panelists, Ryan Cromover and Kristen Davis for joining us. And I want to thank all of you for joining today at this webinar. And we'll be back soon and have a great rest of your day. Bye-bye.
Thanks, everyone.
Thanks,
Bye-bye.
everyone.
Thank you.